So hello, now we are going to discuss about substitution ciphers. So if we talk about substitution ciphers, there can be substitution cipher. There can be two types of substitution ciphers: monoalphabetic substitution cipher and polyalphabetic substitution cipher. So what is the difference between monoalphabetic and polyalphabetic substitution ciphers? So monoalphabetic substitution cipher means one alphabet can be mapped to a fixed alphabet. Like we are talking about English alphabet. So if A can be mixed to D, can be like mapped to D. So every time A will be mapped to D only. If we talk about polyalphabetic ciphers, so in a single encryption scheme, every time A will be mapped to D. But if we talk about polyalphabetic substitution cipher, in single encryption also a letter can be mapped to different alphabet. So these are two different substitution ciphers: monoalphabetic substitution cipher and polyalphabetic substitution cipher. So let's discuss about only the monoalphabetic substitution cipher now. So this it has only the 5 tuples P, C, K, E and D. So P or C is the set of English alphabet. Set of English alphabet. For example, A, B, C up to Z. So it contains 26 values. So similarly, P and C both are set of English alphabet. And if we talk about key is a function mapping phi from set A or set A to A. It's a bijective mapping. It is from P to, you can say from P to P. It is a bijective mapping. So you can it's a kind of permutation. Anytime you can permute it. So you can make a mapping. It's a kind of permutation, and because we have 26 alphabets, so number of permutation will be factorial of 26. So K is a set which has phi, a permutation on P, or permutation on set A, a permutation on alphabets. So what we can write, like E phi x, encryption can be done phi x for all x belongs to P, and d phi x or d phi y, this is, if this is y, then d phi y is equal to phi inverse y, or y belongs to ciphertext. See, where phi inverse is the inverse permutation of phi. Phi inverse is the inverse permutation of phi. So we will discuss about, like, because there are 26 permutations, so brute force attack, like value of factorial 26 comes out to be 4 into 10 raised to the power 26. This is nearly equals to 2 to the power 88. So it is a very large value, so brute force attack is not possible, or nearly computationally difficult for this. You can say it is computationally secure, because 2 raised to the power 88 is a large calculation. So brute force method is not possible. We can, like, if we want to do, with this substitution cipher monoalphabetic, we can go for frequency analysis. So before going into the detail of frequency analysis method, that how cryptanalysis frequency analysis method, I would like to discuss about how we can encrypt it. Here is an example of encryption function phi, permutation phi, and inverse permutation phi. So these are the alphabets A, B, C, D. So here maybe it is written as a capital or a small, but you consider them same. So this is just to distinguish. So A, B, C, D, E, F, G, H. So A can be mapped to X. This is one permutation. B can be mapped to N, C can be mapped to Y. So this can be anything. So that's why I say there are factorial 26 permutations. Now when you talk about decryption function, so this A, if you find A in the cipher text, that can be go to D. If you find F in the cipher text, that can be go to, you search it, O. So like for example, I write simple M double E T, meet me. Now first we want to encrypt it. So M goes to T, E goes to H, again E goes to H, and T goes to M. Then M goes to T and E goes to H. Now let's come for like phi inverse decryption, phi inverse this X. So T goes to here, you see T goes to M, then H goes to E, then again H goes to E, and T goes to M goes to T, and similarly you can decrypt it. So this is how permutation, how substitution cipher, monoalphabetic substitution ciphers work. Now let's come to the cryptanalysis. I already discussed that brute force attack is not possible. Why? Because it is going to be a large value. 2 raised to the power 88 is a large computation which is computationally infeasible. So what are the methods? Like anyone can do a frequency analysis. What is known as frequency analysis? Let me discuss it here. Frequency analysis says that suppose we have a long cipher text. The challenge is to decipher this text. So let us know the text in English and has been encrypted using a monoalphabetic substitution cipher. Now searching all possible keys impractical as the key space is of size factorial 26. So in English, like we can do the frequency analysis. Frequency analysis means there are some letters which occur more than, like for example in English E is the most common letter followed by T, then A. This is the frequency analysis for English alphabet. So what we can do, we can carefully examine the cipher text in the question and work out the frequency of each letter. If most common letter in the cipher text is for example J, then it would seems like the substitution for this is E, because E has the most frequency in English language. If the second most common letter in the cipher text is P, then the substitution is for T. However, regularities of language may be exploited, the relative frequency. Frequency analysis requires logical thinking, intuition, and flexibility and guesswork. So these are the monoalphabetic ciphers. This is frequency analysis, like E comes, like for example, this is a cipher text, here E 7 times. So most of the time which word come Z. So in this we will replace Z with E. So likewise we can replace, and once we replace many of the letter, then we can like formulate it using our common sense or our intuition. So this is how monoalphabetic ciphers work. In the next video we will check some polyalphabetic ciphers and how we can code those ciphers. Thank you.